Well, ladies and gentlemen, welcome to a consumer's guide to choosing a derivative rule multiple times. So today we're going to have multiple derivative rules for the next class. And I like to kind of think about comparing the methods side by side so we can strategically choose a method at the right time. Kind of like the concept of reading a magazine like Consumer Reports. That's our goal. So the situation is, let's suppose that we have this really big, bad-looking derivative. We got numerator, denominator. We have, trig. We have a square root on the top, trig on the bottom. So we need to really think about, some good strategies going forward. So step one, even just writing down, what methods we have learned and kind of keeping it as you are working these problems is really good. So I'm giving you a list here, not handwritten, but already kind of typed out, so you can kind of know which to use and when. I do not recommend, for computational purposes, the limit definition. We haven't done that in a while, and I don't think we need to do that because now our goal is computing things. But you should be looking at power rule, product rule. So this is when you have, the multiplication, the quotient rule, and the chain rule. So I'm just going to kind of write those basic rules, especially the product and quotient. So remember, product is f g prime plus f prime g, and then quotient rule is gf prime minus f g prime over g squared. And then the compositions, we kind of talked about the U approach. Let's actually take a look at the derivative that I gave you. All right, step two, chunculate. This is breaking into smaller chunks. So what I mean by that is, we have this situation. So suppose we want to take the derivative. We want to make sure, that we are chunking this derivative. So we want to write our f and our g in this case, so we can clearly see that it's in quotient rule form. And we will see that in a minute. So I like to write out my numerator and my denominator to make it a simplified problem so that it's really just two more simple derivatives. And, without saying, we want to focus on one chunk at a time. And then when we're done with that, we are going to combine overall results in the final answer. So let's do this. So first thing I would do is immediately write down and I would just focus on one at a time. In fact, I even like writing this as a fractional exponent. So we need to do chain rule here. So du would be negative 18 x squared. F prime would be, let's see if this is u to the 1/2. F prime would be 1/2 u to the negative 1/2. So when I do chain rule, I get 1/2 times 5 minus 6x cubed, negative 1/2. And what I would personally do at this point, put it numerator and denominator. So remember that this goes into denominator. 1 goes in the numerator. So that's our f prime. I'm just going to box key results. I got my f. That's really easy and obvious. My f prime took a lot of work. And for my g, I do the same thing. So my g, I'm actually going to rewrite this as sine x to the 4th. You can do that with trig. Obviously, in this case, my u is sine x. So my du would be cosine of x. So if g equals u to the 4th, so g prime would be, in this case, I would write this as 4u cubed du. And then this is going to be 4 times, let's see, I got u cubed. That's going to be sine x cubed. And then our du is cosine of x. That's our g prime. So I got my key results. So now I use the quotient rule. And I think it is okay in Delta Math if you kind of even just go and use the step like before. So like this is okay, I believe. So I'm going to just write it out. So I got g f prime minus f g prime over g squared. Let's see, so my g is going to be sine 4th x. My f prime is going to be, just write this as 1/2 times 5 minus 6x to the 1/2. And then my f is going to be 5 minus 6x cubed 1/2. And then my g prime is going to be 4 sine of x cubed times cosine of x. All of this is over the square of g. So this is sine x to the, so let's see, if we're squaring the 4, remember we multiply the exponents. So this would be sine 8th of x. Woo! The answer is really, really ugly, but we are done officially. Let's look at another situation. So this one is a little bit, actually a little bit better. It's product rule, obviously. So I like to maybe label this as my f part, so we can kind of see that there's really 2 functions going on here. So this is a product rule. And I'll write my product rule. And then I just write my f. You got to do a little chain rule here. And I'll show you kind of the chain rule shortcut. So if you just take that 3, move that in front, leave the inside alone, take that exponent down by 1, and then just multiply by the derivative of what is inside of the parentheses. I use chain rule. And I can clean this up. 3 times 2 is 6. And we're done. And I'll just kind of like box key results. g then is sine x to the cubed. And this is still kind of a chain rule type of situation as well. So I'm going to say that this is going to be 3 sine of x. So we leave the inside alone. Exponent becomes 2, and then we just take the derivative of the inside. Then our actual real derivative at this point, that. And I'm just going to substitute everything in. So I have x cubed minus 3 cubed. I got g prime, which is 3 sine squared x cosine of x. These are really ugly final answers, but they are the final answers, fortunately. And then I got the f prime g. So then I would write this as 6x x squared minus 3 squared. And then my g is just sine of x cubed. And then we're done. So you really need to break these apart, chunkulate them, because these look like big bad derivatives, but if you kind of break them down into individual derivatives and use things like product and quotient rule, you will be in really, really good shape. So thank you very much, and best of luck.